moving to the next point in chapter 13, symmetry and angle properties of polygon again. But our topic is talking about plane symmetry and their rotational symmetry. The objectives at the end of this session, you all will be able to identify what is a plane of symmetry in 3 dimensions, state the number of plane symmetry, and state the number of axes of rotational symmetry. Okay, do you know what is a cuboid? Yeah, a cuboid is a 3-dimensional set with a length, width, and a height. Here is the figures of a cuboid. Yeah. We have the longer side here is a length, and this is just width, and this is just height. Okay, in the previous session we have learned something related to quadrilateral, and we also revised back about what is a line of symmetry. And how about plane of symmetry? What is it? Can you answer with this? Okay, before we answer to this one, just moving to our topic today, is talking about plane symmetry. The diagram below shows a cuboid cut by a plane symmetrically in 2 different ways. Here, figure A, like you see, this is just the plane which cut a cuboid. Cut in the middle. Okay, this is just the second figure. And also a cuboid, but one just cut in the longer side, yes, surface, and this one is cut the shorter surface. Yeah, so the figure here cut by this plane. This figure also cut by this plane. Okay, so the 2 planes in the middle which cut here we call plane of symmetry. The cuboid said to be asymmetrical to a plane, then that part of one cuboid on one side here, one side of the plane, okay, is a mirror image of the part on the other side of the plane. You see, yeah, one side here and one side here, they are congruent. Yeah, they are congruent. This is 2, this figure and this figure congruent. So the plane is called the plane of symmetry. So we can answer to our question right now. What is a plane of symmetry? A plane of symmetry is a 2D surface. 2D it means 2 dimension. Yeah? It is a 2-dimension surface that can cut a solid into 2 mirror halves. Example: how many planes of symmetry does a cuboid have? Yeah, in the previous, I just show you about 2 planes of symmetry in a cuboid. So can you consider how many planes altogether, yeah, of a symmetry does a cuboid have? A cuboid has 3 planes of symmetry. Here, the figure. Yeah, this is the first one. It cut. Yeah, this is the first, and this is just cut in this surface and this one cut in this surface. So 3 different ways. Can you imagine of another surface which we call plane of symmetry? No more, right? No more. Yeah. Okay, thank you. Okay, move on. Like you know, there are too many different solids which have planes of symmetry. Right now, I just was out about cuboid. So there are too many different solids, such as a cube, a right cylinder, a right triangular prism, a right pyramid, yeah, a right cone, so on. Yeah, there are too many. Okay, so we can talk about their rotational symmetry. Given that a cuboid where side AB is not equal to side BC, rotating about a line XY as shown below. Here, the figure. You also can observe it from your textbook on page 255. Yeah, on page 255, you will see that this is just side AB which not equal to BC. Yeah, which not equal to BC. It's the top surface, and line XY here just cut in the center of the top surface and the below surface. And it's just moving, yeah, it's rotating about the line XY here. You see now AB change to this side. AB change to this side. So the figure is mapped onto itself. Map onto itself. It means we get one order of rotational. And then next, moving one more time. So we get the figure in A and the figure in C right now. Both are the same. It means now it fit to the original shape. So we rotate it for 2 times. We can say that there are 2 orders of rotational symmetry. Okay, so a 3-dimensional figure is said to have rotational symmetry if it repeats itself more than once when it is rotated about a line in one complete revolution. Such a line is called axis of rotational symmetry. So from the example above, we can identify that a cuboid here, we just mark the point here, and PQ is the axis of rotational symmetry. Yeah? It cut the center of a top surface and below surface here. So I just rotated 180 degrees, so I will get this figure right now, which means that the point is moving until here. Yeah. So I rotated 1 time. So when I rotated 1 more time here, 180 degrees, so the point is moving from this to this side, which it just marked the same as the original one, you see. So this cuboid has 2-fold rotational symmetry. Yeah, we fold it or we rotate it for 2 times to get the original shape. So we call rotational symmetry of order 2 about the line PQ. Okay, about the line PQ. Next, example. Does the cube have rotational symmetry? Like the previous one, I also state that the kinds of solid which have plane of symmetry, we have too many kinds of solid. And now cube also is kind of solid. So does it have a rotational symmetry? Okay, we can draw a cube and then draw a line through the center of the cube like this. Yeah, like this. So we can rotate, we can move it, right? So the answer means yes, because of it has a line of symmetry. Okay? We have a line of symmetry, so it has rotational symmetry. So what is the order of rotational symmetry about these axes? Can you guess? If you rotate this one around this arc, how many order do we get? Okay, when we rotate 90 degrees, does it fit or map onto itself? Yes. So how many times of 90 degrees? Yeah, good. There are 4 order of rotational symmetry. How many axes of symmetry does a cube have? Can you count? Yeah, this is 1. From here to there, 1. From here to there, 1. 3. And then this vertex, this vertex, this vertex, this vertex, so forth. Altogether 7. But do not forget that about the surface here also can be. Yeah, there are 6 phases of cube. So 6 small lines. It means that the total axis of a cube has 13. Yeah, there are 13 axes. Okay, it's time for you to do some exercises. So for the following figures here, a tetrahedron. A tetrahedron is 4 sides, 4 rectangular side, triangular of pyramid, 4 faces. A tetrahedron. B, a cone, and C, pentagonal prism. 1. How many axes of symmetry do each of the following shapes have? 2. What is the order of rotational symmetry about each axis? Yeah, you have time to finish your work, and then we are going to do a quiz for 15 minutes. Thank you for your cooperation. Goodbye, everyone. See you next meeting.